This is a lecture 12 about learning about induction motors, and this is about the induction generators. If an induction motor is rotated above the synchronous speed, then it will act as a generator, and induction generator are asynchronous devices. Also, it is seen that at synchronous speed no power is delivered. The reason why there is no power because the difference between the synchronous speed and the operating speed is 0 and the slip of the machine is 0. But if a motor is driven at higher speed, then the synchronous speed will be higher than the running speed of the motor will be higher than the synchronous speed, and the slip will go negative, and the torque will also be negative and starting acting as a generator. That is, there is no torque that the motor is supplying, and externally the torque is being supplied to the motor, and it will deliver active power to the power system in this case. So if you can see from the torque slip characteristics, the generating mode of the machine happens when the slip is less than 0. That is, when the motor is running above the synchronous speed, that is the speed of the shaft of the motor. It is being externally rotated by a prime mover like a wind turbine. The speed will go above the synchronous speed, and when this happens, the slip, that is the synchronous speed minus speed of the motor divided by the synchronous speed into 100, that will be less than 0 in this case, and the speed will be higher than the synchronous speed and the slip will be lesser than, and this region is known as the generating region or the generating mode, and it can be used very efficiently to convert asynchronous sources of mechanical energy like wind turbine and water turbines with uncontrolled or non-regulated flow. So this will cause the prime mover speed to vary with time or not very constant, and such kind of machines can be used to convert into electrical power by using induction motor. To operate an induction motor as a generator, it needs to be run above the synchronous speed. In other words, if a prime mover drives the rotor above the synchronous speed, then the stator flux induces current in the rotor. Then the motor could also work as a generator. So what happens in this case is that the extra power will be generated in the machine, which will be supplied back to the power system using the stator supply. So during the action as a motor, the active and the reactive power was taken from the power system to supply the copper losses and setting up the magnetic field and doing the mechanical work. Now there is no mechanical work. The mechanical work is the torque is negative and the shaft is being rotated above the synchronous speed by a prime mover like a wind turbine as shown in the diagram. So there will be excess active power which should be generated in the machine in this case, and this excess active power will be supplied back to the power system or the grid as the machine acting as a generator. But at the same time, the induction motor will require more reactive power for its generation purpose or for the setting up of magnetic field and supplying the reactance losses, and this excess reactance may cause the power factor to go very low in the power system which is being supplied, or the power grid which is being supplied by the induction generator. So to stabilize the power factor, the reactive requirement or the reactive power required to set up the magnetic field can be supplied from external capacitive banks connected in delta to the stator windings or the stator supply. So in this way it will be possible to supply the active power to the system without any dependence of reactive power requirement from the external grid. That's all. If you like this video, please do like, comment and subscribe.